Good day. Recently, we looked at writing variable expressions for arithmetic sequences where we had a constant rate of change that we could relate to slope. This time, we're going to look at writing variable expressions for geometric sequences. So in arithmetic, we were adding over and over and over again. In geometric, we're multiplying over and over and over again. Now, when we multiply, I don't want you to think, and I just realized I misspelled sequence. I don't want you to think that division is not a part of this. Keep in mind that you can multiply by a whole number just as well as you can multiply by a fraction. And when you multiply by a fraction, it's the same as dividing. So you'll see some of those. Let's go ahead and get right into this. So here we have write an equation to describe the sequence below. Use n to represent the position of a term in the sequence, where n is equal to 1 for the first term. Now, remember the term is like your x. So it's what you put in versus these numbers are what you get out. So this is like your x, this is like your y, each one of these. So write your answer using the decimal and integers. Now, I gave you some information here so that you would understand what we are doing with our first problem and every problem thereon in this skill. First of all, we have the term that we're looking for, that's a sub n, equals a sub 1. All that means is what is the first term? What is the first number? Then we have a common ratio, which is what is being multiplied or divided by. And then we have n minus 1, so we would take whatever we have for n, subtract it by 1, and this is the position in the sequence. So here we have a sub n. Well, we don't know what that is going to be yet because we don't have any term that they've asked us to look for. They just ask us to write an equation. So our first number is 4. Our common ratio, well, think about this. If I go from 4 to 12 and then 12 to 36, I could think of this as multiplying by 3. And if you couldn't see that, then you could also say, okay, well, if I go 36 divided by 12, that's 3. 12 divided by 4, that's 3. So our common ratio would be 3. And notice they already have the n minus 1 there. So we're going to put 4 here and 3 here. Number 2, we've got 15, negative 30, positive 60. Well, think about this. If I divide 30 by 15, it would be 2, just as well as if I divide 60 by 30, it would be 2, and that would be great. But we have this negative in here. So really our common difference, or our common ratio, is negative 2. So a sub n is equal to our first number, which is 15, multiplied by negative 2 raised to n to the negative 1 power. Did I say n to the negative 1? N minus 1 power. So 15, negative 2. Number 3, we have 8, negative 16, positive 32. So a sub n, or the term we would be looking for, is equal to, our first term is 8, we're multiplying by negative 2, raised to the n minus 1 power. We've got negative 2, 8, negative 32. So a sub n is equal to, our first term is negative 2, and it looks like we're multiplying by negative 4 because negative 2 times negative 4 gives me positive 8. And positive 8 multiplied by negative 4 would give me negative 32. Number 5, we've got negative 3, comma 9, negative 27, and I bet you're already thinking, Ms. Clark, well, that's pretty easy. We're multiplying by negative 3, but that doesn't go there, does it? Oh, yes, it does in this case. Whew, I thought I was going to have to write this all over again. So negative 3 is our first term, but we are also multiplying by negative 3. Nice save. Alright, on this one we've got 6, negative 12 to positive 24. So we've got a sub n, or the term we're looking for, would be equal to our first term times our common ratio. So the 6 to negative 12 would be negative 2 again, raised to the n minus 1 power. Number 7 here, we've got 2, 6, 18. Hopefully you see it already. So a sub n is equal to, our first term is 2. We're multiplying by 3. So n minus 1. Number 8, we've got 30, negative 60, 120. So a sub n is equal to, our first term is 30, multiplied by, well, 30 times 2 would give us 60, but this is not positive 60, it's negative 60, so this would be negative 2, raised to the n minus 1 power. Number 9. Got 1, 3, and 9. So a sub n, or the term we're looking for, is equal to the first term times the common difference. Well, 1 times 3 is 3. 3 times 3 is 9, raised to the term minus 1. Number 10, we got 1, negative 2, and 4. So we've got a sub n. How in the world did I get from 1 to negative 2? We must have multiplied by negative 2. So our first term would be 1. Our common ratio would be negative 2, raised to the n minus 1 power. Alright, let's look at number 11 here. We've got 5, 20, 80. And I hear you, you're saying, Ms. Clark, this has got to be harder than this. Well, let's write the first term. We know that 5 times something gives me 20, that's 4. The n minus 1. And guys, this really comes in handy when we get to our last unit of the year, which is exponentials, because we will take this information and actually begin to use it to solve real-world problems. And this is really good for science or anything that has to do with banking, when you're talking about exponential growth of numbers or population or anything like that. So on this one, we have a sub n is equal to, our first term is 4, and our common ratio is 2, and we're raising that to the n minus 1 power. Oh boy, this one looks really good. And at first this might seem a little intimidating, but I want you to know that you know this. And I'm going to promise you and show you that you know it. So here you have negative 3, negative 9, negative 27. What do you notice that they're all doing? Hopefully you said, Ms. Clark, everything is being multiplied by 3. And you would be correct. Now think about this on the bottom. Well, let's make this into a fraction because the other two are fractions. So what do you notice is multiplying by on the bottom? Well, 1 to 5 would be 5, 5 to 5 would be 5. So really we're multiplying by 3/5. So this would go a sub n is equal to, our first term is negative 3 multiplied by 3/5, minus 1. And that's why I told you, when you get to fractions, you might think, well, Ms. Clark, how are you multiplying that? Just think, the same way I can multiply by a whole number, I can multiply by a fraction. And when we multiply by a fraction, what we know is fractions denote division. So that's how that can happen. Oops. Oh boy, now we got a decimal. I know you guys love decimals better than you do fractions, but that's okay. I like them both. So well, let's see. If we're going to go from 0.67 to 2.68, we could go ahead and divide those. Or we could think, okay, what can I multiply this by that would end in an 8? Well, we can multiply by 4, but that won't help us. Or actually, will it? Let's see. Let's see. I'm gonna go somewhere down here. I'm gonna do 0.67 times 4. Let's see, 8, 24 plus 2 gives me 6, 2, and I've got 2 decimal places behind the decimal, so I move my decimal place 2 places to the left. Well, what do you know? So our first term is a sub n is equal to 0.67, and our common ratio is 4, and minus 1. Alright, what if you decide to go past the 80s and you get to something like this? You're not going to change your process, you're just going to take it one step further. So here we have 3 to 15, 15 to 75, so we know we're multiplying by 5. So the equation would be a sub n is equal to our first term times our common difference, n minus 1. Now, if you notice, we have a sub 4 here, so what they're saying is find the fourth term. So to do that, we would do 3 multiplied by 5, 4, so we would replace n with 4 minus 1. And then we would do 3 multiplied by 5 raised to the third power, because 4 minus 1 is 3. So remember, with order of operations, we're always going to do the exponent first. So we would have 3, or 5 to the third power, 5 to the first power is 5, 5 to the second power, meaning 5 times 5 is 25, 5 to the third power, meaning 5 times 5 times 5, well, that would be 125. And then we're going to take that and multiply it by 3. Well, 3 times 5 is 15. Carry the 1. 3 times 2 is 6 plus 1 is 7. And then 3 times 1 is 3. So we would have 375. And if you want to check it, just multiply, because it's the fourth term, multiply 75 times 4, or 75 times 5, excuse me, and you would see that you would get the same answer. So we've got 3 and 5, and then our answer here is 375. All right, that's it for this one. Go on and get that 100.